In Lesson 3.3, we will discuss properties of logarithms. In Video 3.3.2, the learning target will be for students to apply properties of logarithms. In Example 2, we will be asked to simplify logarithms using the properties we've already discussed. The product property, the quotient property, and power property can all be applied in certain instances to evaluate logarithms. Now, in Example 2, we're asked to evaluate log base 2 of the cube root of 32. Now, what we want to know is what log base 2 of the cube root of 32 is equal to. That's unknown. So I'm going to put a variable x for the unknown quantity. Now, we know that every logarithmic equation can be rewritten exponentially. So this equation right here can be rewritten as 2 to what power is equal to the cube root of 32. Now, we have base 2 here of our exponential function. 2 is our base, x is our exponent. And what we want to figure out is the value of x. Well, one thing I can do is rewrite 32 as a base of 2. So I have the cube root of 2 to the 5th power is the equivalent of 32. 2 times 2 times 2 times 2 times 2 is going to give me 2 to the 5th, which is equal to 32. So rewriting 32 as base 2 allows me to have both sides of my equation in the same base. Now, the third root is the same as the 1/3 power. So really I have 2 to the 5th raised to the 1/3 power. In applying properties of powers, if I have a power raised to another power, then I multiply those exponents. So I have 2 to the x is equal to 2. 5 times 1/3 is 5/3. So since 2 to what power is equal to 2 to the 5/3, since my bases are the same, that implies my exponents are equal. So I get x equals 5/3. And that is the value of log base 2 of the cube root of 32 is 5/3. In the last example, we were asked to evaluate log base 2 of the cube root of 32. And we went about solving that by rewriting the logarithmic expression in exponential form. Now, I want to go through an alternate method to solving this problem. In this alternate method, we do not rewrite the logarithmic expression in exponential form. But what we rather do is we will rewrite 32 as 2 to the 5th, right? So we had the cube root of 2 to the 5th power, because 2 to the 5th power is 32. And what we would do from there is we would rewrite the cube root as the 1/3 power, just like we did in the previous example. And then we have log base 2 of 2 to the 5/3. And there's this property we learned about in Lesson 3-2 where if the base of our logarithm and the base of our exponential term or input for our logarithm are equal, they cancel out and I'm left with just the exponent, which was 5/3. So anytime the base of our logarithm matches the base of our exponential term, because logarithmic functions and exponential functions are inverses of each other, they undo one another, and that leaves me with 5/3. Another way to come up with evaluating log base 2 of the cube root of 32, so I just thought I would show both methods, and you can pick which one you prefer. In example 2 part B, we're asked to evaluate 3 times natural log of e to the 4th minus 2 times natural log of e squared. And if we're going to evaluate this, we're going to rewrite this as a single logarithm. So the first property I'm going to apply here is the power property. I can move up this 3 to be a power next to the power of 4. So really what we have is natural log of e to the 4th cubed. Okay, applying the power property. Minus natural log of e squared squared. Moving this power of 2 up as well. So that's applying the power property, which we discussed in the last video. And I can simplify farther by multiplying my exponents here. When you raise a power to a power, that property is that we multiply the exponents. So really, I have natural log of e to the 12th minus natural log of e to the 4th. That is just applying the power to a power property. And from here, we can apply the quotient property to combine these logarithms. Because our logarithms have the same base, they're both natural log, which means they're base e. If we're subtracting 2 logarithms with the same base, we can combine that by using the quotient property. So I have a single logarithm, single natural log, and I'm going to have natural log of e to the 12th over e to the 4th. Now, I can simplify this even further because e to the 12th and e to the 4th can be simplified because I have the same base here. E to the 12th divided by e to the 4th is really e to the 8th, right? When you have the same base, which we do, base e, and that exponential term is raised to a power on both top and bottom, that's called the difference property because we would subtract our exponents. So we're applying properties of powers as well as properties of logarithms. So e to the 12th divided by e to the 4th is e to the 8th power. And then, since our natural logarithm is base e and our exponential term also has a base e, they cancel out and leave me with 8 as my result. Make sure that when you're canceling out a natural log, or any log rather, that the base of your logarithm and the base of your exponential term or input are the same before you cancel them out. If those bases are not the same, then they cannot be canceled. In example 2 guided practice, we're asked to evaluate log base 3 of the cube root of 81. What I would like you to do is to evaluate this logarithm and then select your answer, A, B, C, or D, and press submit.